Geometry. In this last video, we'll be using the Pythagorean theorem twice again to find space diagonals. Okay, so space diagonals, as you saw in the diagram, are going from one vertex to the other in a prism. So space diagonals are what I'm highlighting in yellow. Now, to figure out that distance, we need to use Pythagorean theorem to figure out what these two legs are. And I'm going to draw it in this other triangle too. We already know that the longer leg in both of those, so we know that this longer green leg is 10 inches, but we don't know what this bottom leg is yet. And so that's where we're going to use our Pythagorean theorem. So we know that this side measures 1 inch. This side right here on this bottom part, on the bottom base of that prism is also 1 inch. Since this is a rectangular prism, we know that this is a right angle. And so basically we've got a right triangle where one side measures 1, the other leg measures 4. So our first Pythagorean theorem is going to look like 1 squared plus 4 squared equals, we're going to leave that as c squared. So that turns into 1 plus 16 equals c squared. I'm left with 17 equals c squared, which means that that smaller leg of the green triangle, this measures square root of 17. So now we can use the Pythagorean theorem a second time to figure out that yellow highlighted space diagonal. So we know both of our legs. One leg measures 10. The other leg measures the square root of 17. So square root of 17, and we're going to square this. And we're looking for the yellow highlighted space. I know I'm going to call that, let's call that x. All right, 10 squared is 100. Now, if I got the square root of 17 and then I'm squaring that, these two things, the radical and then raising it to a power of 2, they undo each other. They're inverses. So what that means is that they kind of cancel each other out. So all I'm left with is the 17, which is the number underneath the radical. So 100 plus 17 is 117, equals x squared, which means that the space diagonal measures 117, the square root of 117. And that cannot be simplified. Length of space diagonal. Okay, so let's do this other one now. So in the triangle that I'm highlighting in blue here, we've got these two bottom legs. So we need to figure out the leg of the green triangle, which is the hypotenuse of the blue triangle. So the first Pythagorean theorem, is going to look like 6 squared plus 3 squared equals, let's call that c squared. So I'm left with 36 plus 9 equals c squared. 36 plus 9 is going to give us 45. And we can simplify, when we take the square root of 45, we can simplify that into root 9 times root 5 equals c. Square root of 9 is just going to be 3. So I'm left with 3 root 5 equals c. So the smaller leg of that green triangle measures 3 root 5. So the other Pythagorean theorem that we're going to set up that will help us find the length of the space diagonal is going to be 3 root 5. We're going to square that, plus 11 squared equals, let's call the space diagonal y squared. Okay, now when we're squaring something, what we're doing is we really have, we're taking that thing and we're multiplying it by itself twice. And I already know that 11 squared is 121, so I'm just going to simplify that. All right, so I've expanded the 3 root 5. And so now to deal with this, what happens is I multiply everything on the outside. So that turns to 9, because 3 times 3 is 9. And then root 5 times root 5, well, that becomes root 25. But I know that the square root of 25 is just 5. So this becomes 9 times 5. Plus 121 equals y squared. Okay, And then 9 times 5 is 45. So I have 45 plus 121 equals y squared. So I'm left with 166 equals y squared. Then I take the square root. So that space diagonal measures the square root of 166. All right, thanks for watching.